are aircraft that exist to complete a mission, and then there are aircraft that exist
to make a statement.
The story of the B-36 Peacemaker and the B-29 Superfortress is not simply about bigger engines or longer wings. It is about a turning point, a moment when strategic bombing evolved from the desperate urgency of World War II into the cold, calculated logic of nuclear deterrence. One era ended in fire. The next began in silence. It starts with the B-29. During World War II, the Boeing B-29 Superfortress represented something radically new. It was not just another bomber added to an existing lineup. It was a technological gamble. Engineers were being asked to solve problems that had never fully been solved before. How to operate effectively at extreme altitudes. How to protect crews from the brutal cold and thin air of the upper atmosphere. And how to maintain defensive firepower without exposing gunners to near certain death. The answer came in the form of pressurized crew compartments, a breakthrough that allowed airmen to function in relative comfort at altitudes exceeding 30,000 feet. Instead of wearing cumbersome oxygen gear for entire missions, crews worked inside sealed, climate-controlled sections of the aircraft. It sounds ordinary now. At the time, it was revolutionary. Even more futuristic was the remote-controlled gunnery system. Gunners no longer stood in isolated, exposed turrets. They operated weapon systems from within the fuselage, using analog computers and periscopic sights to control multiple gun positions. The B-29 was, in many ways, an early step toward the networked warfare systems that would define later generations of aircraft. But the B-29 did more than push engineering boundaries. It carried out missions that changed the course of history. It demonstrated that long-range, high-altitude precision bombing could be sustained across vast distances. It proved that strategic air power was no longer theoretical, it was decisive. And yet, as World War II came to an end, the global situation did not relax. It tightened. The alliance that had defeated the Axis powers began to fracture. Political distrust replaced battlefield cooperation. The United States faced a new strategic reality. Potential adversaries were separated not by borders, but by oceans. Air power would have to stretch farther than ever before. The requirement was stark and uncompromising. An aircraft had to take off from the continental United States, fly across the Atlantic or Pacific, strike a distant target, and return home without refueling. No forward bases, no staging areas, total autonomy. That requirement gave birth to the Convair B-36 Peacemaker.
If the B-29 felt advanced, the B-36 felt immense. Its wingspan stretched wider than a football field. Standing beneath it, one could feel the scale physically, the shadow it cast, the quiet intimidation of its size. It was the largest mass-produced piston-engine aircraft ever built, and its presence alone suggested that it belonged to a different category of machine.
Inside, the scale became even more apparent. The B-36 was not a cockpit with attached compartments. It was almost a flying structure. The forward and rear pressurized sections were connected by a narrow cylindrical tunnel that ran through the bomb bay area. Crew members who needed to move between sections did not simply walk. They lay on a wheeled trolley and pulled themselves through the tube, suspended inside the belly of the aircraft while thousands of feet above the earth. That detail captures something essential about the B-36. It was engineered not just for distance, but for duration. Flight endurance could reach 40 hours in the air, not as a publicity stunt, but as an operational expectation. Crews rotated through rest bunks. Meals were prepared mid-flight. Fatigue was managed like another navigational variable. Time ceased to be measured in simple hours and instead became a matter of sustained concentration and discipline. Then there was the engine configuration, a transitional design that perfectly reflected its historical moment. The early B-36 variants carried 6 massive radial piston engines mounted in a pusher configuration, their propellers positioned behind the wings. Later versions added 4 jet engines in twin pods. The phrase 6 turning 4 burning became shorthand for this unusual combination. It was not merely aesthetic. The piston engines provided fuel efficiency for long-range cruise. The jets delivered bursts of speed when required.
The B-36 straddled 2 technological eras at once, part propeller-driven giant, part emerging jet-age platform.
Nicknamed Magnesium Overcast, the aircraft's metallic skin shimmered in high-altitude sunlight. But beneath that reflective exterior was a far more serious purpose. The B-36 was designed to carry the heaviest nuclear weapons of its time. Its cavernous bomb bays could accommodate payloads that earlier bombers simply could not. This capability defined the early Strategic Air Command doctrine. The goal was not constant warfare. It was deterrence. The mere fact that a B-36 could launch from American soil, traverse an ocean, and deliver a devastating strike without support reshaped global power calculations. Distance no longer guaranteed safety. Maintaining such an aircraft was a monumental task. The radial engines were powerful but temperamental. The electrical systems were complex. The magnesium-rich components required careful handling to prevent corrosion and fire hazards. Ground crews worked tirelessly to keep the fleet operational, fully aware that each aircraft represented not just hardware, but strategic leverage. And yet, despite its size and capability, the B-36 was never intended to be permanent. Technology moves quickly, especially under the pressure of geopolitical rivalry. As jet propulsion matured, faster and more agile bombers entered service. The Boeing B-52 Superfortress, fully jet-powered, began to assume the long-range nuclear role. The B-36 gradually stepped aside, but it would be a mistake to view it as obsolete. It was a bridge, a crucial one. Without the innovations pioneered by the B-29, the B-36 could not have existed. Without the B-36, the early Cold War deterrent posture would have lacked credibility. Each aircraft was a chapter in a larger narrative about how nations adapt to new realities. Looking back, the history of the B-29 and the B-36 is not only about aviation milestones. It is about the psychology of an era, about how technological ambition rises in response to fear, about how engineering answers strategic uncertainty with metal and fuel and altitude. These aircraft flew high above the clouds, but their significance remained grounded in politics, diplomacy, and the fragile balance of power. The roar of their engines carried more than payloads. It carried the weight of a world learning to live under the shadow of unprecedented destructive capability. They were machines, yes, but they were also symbols of innovation, of anxiety, and of a moment when the sky itself became the stage for a new kind of global equilibrium. And yet even that isn't the whole picture, because when we talk about aircraft like the B-29 and the B-36,
it's easy to get lost in the specifications. Wingspan, range, horsepower, payload. Numbers feel solid, reassuring. They give us something measurable.
But behind every one of those numbers were human beings trying to solve problems that had no precedent. Take a think the development process alone. The B-29 program nearly collapsed under its own ambition. It demanded new manufacturing techniques, new materials, new training protocols. Entire factories had to be retooled. Workers were learning as they built. Engineers were pushing pressurization systems that had barely been tested at scale. Early models suffered engine fires, structural stress, mechanical failures. Progress did not come smoothly. It came through iteration, accident, correction. And that pattern repeated with the B-36, only on an even larger canvas. The B-36 was conceived during World War II, when there was real concern that Britain might fall and the United States would need to strike Europe from its own shores. By the time it became fully operational, the war it had been designed for was over. Suddenly, it was no longer a contingency bomber for Nazi-occupied Europe. It was a cornerstone of Cold War deterrence. That shift matters because it meant the aircraft's mission was psychological as much as operational. The B-36 rarely dropped bombs in anger. Instead, it sat on runways, flew training missions, performed readiness exercises, and demonstrated capability. It existed to be known, to be seen in photographs, to be factored into calculations by planners thousands of miles away. Its power lay in potential. With the celebrated B-17, engineered by the Boeing Corporation. The piston engines, 6 Pratt & Whitney R4360 Wasp Majors, were among the most complex reciprocating engines ever built. Each one had 28 cylinders arranged in 4 rows. They produced enormous power, but they demanded careful monitoring. Oil consumption was high. Cooling systems had to perform flawlessly. The pusher configuration meant airflow behaved differently across the wings, adding another layer of aerodynamic nuance. But then there were the added jet engines on later models. They improved dash speed and takeoff performance, but they increased fuel consumption and maintenance demands. The aircraft became a study in compromise, range versus speed, endurance versus agility, innovation versus reliability. Inside the aircraft, life followed its own rhythm.
A 40-hour mission meant more than long hours at the controls. It meant navigating through shifting weather systems over open ocean. It meant recalculating fuel burn under unexpected conditions. It meant maintaining communication discipline across extended periods of monotony punctuated by moments of intense focus.
Crew coordination was essential. Pilots, navigators, flight engineers, radio operators, gunners, each role mattered. And because the aircraft was so large, physical separation became part of the challenge. The pressurized tunnel between forward and aft compartments wasn't just a novelty, it was a logistical necessity. Repairs or coordination sometimes required a crew member to traverse that narrow tube isolated inside metal and air, while the world passed far below. There is something almost surreal about imagining that scene. A man suspended in a small wheeled cart, pulling himself through a cylindrical passage inside a machine that itself is moving hundreds of miles per hour at altitude. It feels less like World War II aviation and more like early space flight. In a way, that comparison isn't far off. Both the B-29 and the B-36 were stepping stones toward a different understanding of distance and altitude. They helped normalize the idea that humans could operate effectively in environments that had once been considered extreme. Pressurization, systems redundancy, long-duration crew operations. These concepts would later become fundamental to aerospace design. But at the time, they were still being refined through trial and error. Key to Care Command, under leaders like General Curtis LeMay, built an entire doctrine around readiness and reach. Aircraft had to be maintained at a moment's notice. Crews trained constantly. The assumption was simple. If deterrence failed, response had to be immediate and overwhelming. The B-36 fit that doctrine precisely. It could loiter at high altitude, beyond the effective range of many early interceptors. It could carry payloads that made conventional bombing seem almost secondary. And most importantly, it could do all of this without relying on foreign bases that might become politically unreliable. Distance became insulation. But distance also became a vulnerability as air defense systems evolved. Radar improved, jet interceptors matured, surface-to-air missile development accelerated. The very qualities that made the B-36 formidable in the late 1940s began to look less certain by the mid-1950s. History rarely pauses for admiration. The arrival of fully jet-powered bombers marked another shift. Aircraft like the B-52 brought higher speeds, higher altitudes, and greater adaptability to the evolving strategic environment. The B-36, for all its size and endurance, could not match that momentum indefinitely, and so it phased out quietly. No dramatic final mission, no symbolic last stand. It simply completed its service life and made way for the next generation. That, too, says something about the era. These machines were not built for legacy in the romantic sense. They were built to meet immediate strategic needs. When those needs changed, the hardware changed with them. Yet the influence of the B-29 and B-36 lingers. They reshaped how military planners thought about global reach. They demonstrated that technological scale could redefine geopolitical boundaries. They forced advancements in metallurgy, propulsion, pressurization, electronics, and logistics that spilled over into civilian aviation and aerospace research. Even the cultural memory of these aircraft carries weight. The B-29 is forever tied to the closing chapter of World War II. The B-36 is inseparable from the early anxious years of nuclear standoff. Together they form a continuum from total war to uneasy peace maintained by overwhelming capability. If you trace that arc carefully, you begin to see something deeper. The B-29 represented urgency. It was built to win a war already underway. The B-36 represented anticipation. It was built to prevent a war that might never come. One aircraft closed a chapter. The other tried to hold the next chapter in suspension. And in that contrast lies the real story, not just of two bombers, but of a world adjusting to a new balance of power. The sky had always been a battlefield. With these aircraft, it became something else as well, a silent guarantor of deterrence, a platform where technology and geopolitics intertwined at unprecedented scale. They were massive, they were complex, they were imperfect, but they marked the moment when strategic air power stopped being purely tactical and became existential.
And that shift from bombing campaigns to nuclear calculus is what truly defines the journey from the B-29 Superfortress to the B-36 Peacemaker.
And if you sit with that idea for a moment, existential, it begins to feel heavier than any bomb these aircraft ever carried. Because what changed between the B-29 and the B-36 wasn't just range or payload, it was the meaning of flight itself. During World War II, air power was immediate. A mission had a target had coordinates. Crews briefed, took off, flew into flak, and fighters dropped their bombs and came home if they were lucky. Success or failure was measured in visible damage, destroyed factories, shattered infrastructure. Strategic bombing was brutal, but it was tangible. By the time the B-36 came into full operational service, the logic had shifted. The aircraft might train for years and never release its primary weapon in combat. Its effectiveness was measured not in impact craters, but in restraint. In the calculations of adversaries who knew that if escalation occurred, the consequences would be catastrophic. That's a different kind of mission to carry. Imagine sitting in the cockpit of a B-36 during a long-range exercise. The engines droning, 6 propellers pushing through the thin upper air, jets silent unless needed. The earth below reduced to abstraction, cloud layers, coastlines, open ocean. Somewhere beyond the horizon are cities you have never seen, people you will never meet. Your role is to be ready to cross that horizon if ordered. There's a quiet tension in that readiness. Not the immediate adrenaline of combat, but a steady awareness that what you represent is larger than yourself. The aircraft isn't just metal and fuel, it is policy made physical, in demand, and with secret restraints as ongoing and routine. Pre-flight inspections were meticulous. Ground crews checked fuel lines, inspected control surfaces, monitored hydraulic systems. The sheer size of the wings required careful attention, flexing under load, responding to turbulence. Maintenance hangars became ecosystems of expertise. Specialists understood particular engine quirks. Others monitored electrical networks that seemed almost labyrinthine. It's easy to romanticize these machines from a distance. Up close, they were stubborn. They leaked oil. They required constant adjustment. The R-4360 engines, powerful as they were, demanded respect. Overheating could cascade into serious mechanical issues. Crews developed habits, rituals almost, for listening to subtle changes in engine tone. Slight vibration could mean something. In that sense, the B-36 was not unlike a ship at sea. It had presence, it had temperament, it required teamwork not just in flight, but on the ground. And like a ship, it operated across vast stretches of emptiness where self-sufficiency was essential. Strategically, the aircraft's value lay in autonomy. It did not depend on fragile alliances for forward basing. In a Cold War climate where diplomatic relationships could shift quickly, that independence was priceless. It allowed planners to build deterrence around geography rather than politics. But independence came at a cost. The aircraft's immense size limited the number of airfields capable of supporting it. Runways had to be reinforced. Hangars had to be expanded or purpose-built. Infrastructure followed strategy. Entire bases evolved around accommodating this single type of machine. That kind of commitment reflects how seriously policymakers regarded the threat environment. The early Cold War was not abstract for them. It was immediate. The memory of global war was still fresh. The atomic bomb was no longer theoretical. The question was not whether such weapons could be built. It was how they would shape the future. In that context, the B-36 became more than a bomber. It became a reassurance to some and a warning to others. Meanwhile, technological momentum continued to build. Jet propulsion improved rapidly. Air defense systems grew more sophisticated. Radar coverage expanded. What had once seemed unreachable airspace became increasingly contested. The B-36's high-altitude strategy, effective in the late 1940s, faced growing scrutiny as interceptor capabilities advanced. This constant race, offense versus defense, is a recurring pattern in military history. Each innovation triggers a response. Each response demands adaptation. The B-36 existed in a brief window where altitude and range offered decisive advantages. That window did not remain open forever. When the B-52 entered service, fully embracing jet propulsion, it signaled the next evolution. Faster, more flexible, more adaptable to changing delivery profiles. The torch passed not dramatically, but inevitably. Still, the legacy of the B-36 remained embedded in doctrine. Long-range global reach became non-negotiable. Crew endurance procedures refined during those 40-hour flights informed later operations. Engineering lessons about materials, systems integration, redundancy, filtered forward. Even the psychological framework of deterrence matured around the capabilities these aircraft demonstrated. And what about the B-29 in all of this? It never disappeared from the narrative. Its operational history had already etched it permanently into public memory. It represented the peak of wartime piston engine bomber design. It introduced technologies that were ahead of their time. It closed the chapter on one kind of global conflict. In contrast, the B-36 opened a chapter defined ionite. Together, they form a sequence not just of aircraft models, but of strategic philosophy. One built for decisive action, the other built for calculated restraint. There's something profoundly human in that progression. We build tools to survive immediate threats. Then we build larger, more complex systems to prevent the next catastrophe. And somewhere along the way, those systems become symbols of both security and fear. The B-36 Peacemaker carried a name that almost feels ironic. Peacemaker, a machine capable of delivering unprecedented destruction, named for the peace it was intended to preserve. That duality captures the essence of early Cold War strategy. Stability through overwhelming potential. And if you trace that line back to the B-29, you see the transition clearly. From bombing campaigns meant to end a war, to aircraft meant to ensure that the next war would never begin. With the celebrated B-17, engineered by the Boeing Corporation. The altitudes were the same, but the meaning of what flew through them had shifted. That is the true story of the B-29 Superfortress and the B-36 Peacemaker. Not just larger wings or longer range, but the moment when aviation stopped being merely a tool of war and became an instrument of global equilibrium, balanced precariously on technology, fear, and the fragile hope that readiness might be enough to prevent catastrophe. And even that hope, that readiness alone could prevent catastrophe, was never entirely stable, because deterrence depends on belief. It depends on the other side believing that you can do what you say you can do, and that you will if pushed far enough. The B-36 had to be credible, not just technically capable, but visibly capable. Its size, its range, its payload capacity, all of it had to translate into psychological weight. That's why exercises mattered so much. Long-range training missions weren't simply about pilot proficiency. They were rehearsals for scenarios everyone hoped would never unfold. Crews practiced navigation across featureless ocean expanses. They simulated strike routes. They drilled emergency procedures repeatedly, because the margin for error at that scale was thin. A 40-hour mission left little room for improvisation. Fatigue management became a science in itself. Rotating rest schedules, controlled lighting inside compartments, strict procedural checklists to avoid small mistakes compounding into larger ones. In many ways, these aircraft demanded a kind of discipline that foreshadowed later space missions, sustained operations in isolation, dependent entirely on system integrity. And the systems were vast. Fuel management alone required constant calculation. The B-36 carried enormous quantities of fuel to achieve intercontinental range. Weight distribution had to be carefully balanced. Any inefficiency in engine performance could ripple through the entire mission profile. Engineers and navigators worked in quiet partnership, tracking consumption rates against distance and weather conditions. Whether that unpredictable adversary remained a constant variable. High-altitude winds could alter timing significantly. Ice accumulation posed hazards. Thunderstorm systems had to be avoided. Despite all the mechanical power on board, nature still set the outer limits. There's something grounding in that. For all its technological ambition, the B-36 still had to respect the sky. On the geopolitical stage, the aircraft symbolized a new kind of global awareness. The Earth was no longer divided into distant theaters. It was connected by flight paths. A target thousands of miles away was no longer abstract. It was reachable. That realization reshaped military planning. It reshaped diplomacy. It even reshaped public consciousness. The idea that oceans no longer guaranteed safety altered how nations viewed vulnerability. And vulnerability is a powerful motivator. The B-36 program unfolded alongside debates within the U.S. defense establishment. Some questioned the cost. Others argued that reliance on manned bombers would eventually give way to missile technology. There were disagreements about strategy, whether air power alone could ensure security. But in the late 1940s and early 1950s, before intercontinental ballistic missiles matured, the B-36 filled a crucial gap. It provided a tangible operational capability during a period when nuclear strategy was still being defined. That transitional nature is important. The aircraft was both culmination and bridge. It represented the ultimate expression of piston-engine bomber design, even as it incorporated early jet propulsion. It embodied lessons learned from the B-29 while pointing toward the fully jet-powered bombers that would follow.
Technological evolution rarely draws clean lines. It overlaps, it layers, it carries forward certain ideas while discarding others.
The B-36's pusher propellers, for example, were chosen to improve aerodynamic efficiency at cruise. Yet that configuration also introduced maintenance complexities and noise patterns unfamiliar to crews accustomed to traditional tractor layouts. Innovation always comes with trade-offs. And still, when you look at photographs of the aircraft, that immense wing stretching outward, the multiple engine nacelles lined in disciplined symmetry, it's hard not to feel a sense of awe. Scale does that. The B-29 inspired admiration for its sophistication. The B-36 inspired something closer to disbelief. It seemed almost excessive, almost too large to belong to the same lineage. But the celebrated B-17, engineered by the Boeing Corporation. That's what Orm duress. What a lineage it had. Without the B-29's success in pressurization systems, long-range logistics, and remote weapons control, the B-36 would have lacked a foundation. The Superfortress proved that complex systems integration could work at operational scale. It normalized high-altitude endurance missions. It demonstrated that industrial capacity could be mobilized around advanced aeronautical concepts. The Peacemaker inherited those lessons and magnified them. Yet both aircraft shared something quieter, vulnerability of the human element. No matter how large or advanced the machine, it ultimately depended on crews who were human, who grew tired, who made judgments, who felt the weight of responsibility. Training could reduce error. Discipline could mitigate risk. But the psychological dimension remained. To sit in an aircraft capable of carrying nuclear weapons, to understand what that implies, requires a particular mindset. Not aggression necessarily, not even bravado, but steadiness, a capacity to operate professionally within systems designed for consequences that most people hope never occur.
That steadiness became part of the Cold War ethos.
Aircraft stood on alert. Crews maintained readiness. The visible machinery of deterrence continued quietly in the background of everyday life, and for many years it held. Eventually, ballistic missiles would assume much of the strategic nuclear burden. Submarines would carry weapons beneath oceans. Technology would become faster, less visible, more automated. But before the transformation fully matured, there was this moment, this era of massive bombers poised at the edge of two worlds. The B-29 marked the climax of one global conflict. The B-36 marked the uneasy beginning of another kind of standoff. And when we look back at them now, separated by decades, it's tempting to see them as relics, museum pieces of polished aluminum and preserved rivets. They were once the front line of an invisible boundary. They represented the belief that preparedness could stabilize uncertainty, that engineering could shape geopolitics, that power, held visibly and credibly, might prevent escalation. Whether that belief was fragile or resilient is still debated. What is undeniable is this: the arc from the B-29 Superfortress to the B-36 Peacemaker traces one of the most profound transitions in modern history. From total industrial war to strategic nuclear equilibrium. Two eras. And between them, a world learning, cautiously, imperfectly, how to live under the shadow of its own technological capability. And maybe that shadow is the most important part of the story. Because shadows don't announce themselves. They stretch quietly, lengthening as the sun moves. The B-29 cast one kind of shadow, immediate, visible, defined by wartime urgency. The B-36 cast another, broader, heavier, less visible, but far more consequential. One aircraft ended a global conflict. The other existed to ensure the next one never fully ignited. With the celebrated B-17, engineered by the Boeing Corporation. But history is never as clean as doctrine suggests. The early Cold War years were filled with uncertainty. Intelligence was incomplete. Assumptions shifted. Planners built strategies around best estimates, worst-case scenarios, and rapidly evolving technologies. In that environment, the B-36 was more than hardware. It was reassurance in aluminum form, and reassurance matters. Imagine the internal discussions in strategic command centers during those years. Maps spread across tables, range arcs drawn in pencil, target circles calculated with slide rules and early computing tools. The question was always the same: can we reach them, and can we return? With the B-36, the answer was yes. Yes shaped diplomatic posture. It influenced negotiations. It gave weight to statements that might otherwise have sounded hollow. The aircraft didn't need to fire a shot to exert influence. Its capability spoke in advance. Yet even as it symbolized strength, it also revealed limits. Speed was becoming more important than endurance. Reaction time mattered. Radar networks improved. Early warning systems shortened the window between detection and interception. The B-36, designed around altitude and range, began to look vulnerable in a world accelerating toward supersonic flight. And this is where its transitional identity becomes most clear. It was born of piston engine mastery, but matured in the dawn of jets. It was conceived in the logic of World War II, but operated in the logic of nuclear standoff. It was both culmination and placeholder. That tension gives the aircraft its character. There's something almost poetic about its engine arrangement. 6 propellers quietly turning, 4 jets waiting to burn. It sounds like a metaphor for the era itself. The old world still spinning, the new world igniting beneath it. And for the crews, that transition wasn't theoretical. Pilots trained on earlier bombers had to adapt to handling a machine of extraordinary scale. The wings flexed noticeably in turbulence. Control responses felt different. The sheer mass altered how the aircraft moved through air. Landing required precision. Takeoff demanded runway length that few airfields could provide. Every mission reinforced the awareness that this was not an ordinary bomber. At altitude, the sky seemed calm, but inside the cockpit, there was constant calculation. Fuel burn, engine temperature, navigation drift, communication checks. The longer the flight, the more subtle the challenges became. Fatigue dulled edges. Systems demanded vigilance. And still, the aircraft flew. It flew across oceans and back again. It flew through exercises designed to simulate worst-case scenarios. It flew as proof that intercontinental reach was no longer science fiction.
Meanwhile, the world below adjusted.
Civilian aviation began to benefit from wartime research. Pressurized cabins became standard. Long-haul flights entered commercial service. The same engineering principles that enabled strategic bombers eventually made global travel routine. It's an odd symmetry. Technologies developed for war, quietly shaping peace. The B-29's influence can be traced into that civilian transformation directly. The B-36's influence is subtler, embedded in strategic frameworks rather than airline routes, but both contributed to a world where distance shrank and connection accelerated. There's also a deeper philosophical thread running through their history. The B-29 represented decisive application of power. It was designed to bring a war to its conclusion. Its missions had immediate objectives. Its results were visible. The B-36 represented conditional power. It was designed to exist in readiness. Its objective was prevention. Its results were measured in what did not happen. That distinction is profound. It marks the shift from victory through force to stability through deterrence, from ending wars to avoiding them, from visible destruction to invisible balance. And yet, deterrence is inherently fragile. It relies on rational actors, on clear communication, on mutual understanding of consequences. The B-36 was one piece in that delicate structure, a physical reminder that escalation carried unacceptable risk. When newer systems emerged, faster jets, missile platforms, submarine-based deterrence, they didn't erase the importance of what came before. They built upon it. They refined the architecture of global balance that aircraft like the B-36 helped establish. Eventually, the Peacemaker's massive wings no longer filled active duty ramp. The era of giant piston engine bombers ended, but the logic they embodied continued. Today, when historians look back at the arc from the B-29 Superfortress to the B-36 Peacemaker, they're not just studying aircraft specifications. They're studying a pivot point in human history. A moment when technological capability outpaced moral certainty. A moment when the sky became not just a battlefield, but a boundary line in a new kind of global equation. Complex, occasionally temperamental, they demanded extraordinary resources, but they reflected the anxieties and ambitions of their time with remarkable clarity. Metal shaped by fear, aluminum structured around hope, power engineered for restraint. And in that duality between action and anticipation, between war and deterrence, the true legacy of the B-29 and the B-36 endures.
Not just as machines, but through.
But as symbols of a world learning, cautiously and imperfectly, how to manage the consequences of its own ingenuity. And if you step back even farther, beyond the hardware and the doctrine and the airfields carved into concrete, you begin to see something else. You see how quickly necessity can transform imagination into reality. In the early 1940s, the idea of routinely flying tens of thousands of feet above the Earth in a pressurized aluminum cylinder still felt audacious. Within a decade, that audacity had become standard practice. The B-29 helped normalize it. The B-36 stretched it to the edge of what was mechanically and logistically sustainable. There's a certain rhythm to that progression. First, survival demands innovation. Then, fear demands scale. The B-29 emerged from urgency. Factories ran around the clock. Supply chains strained. Engineers pushed metallurgy and electronics further than anyone had before. The goal was clear and immediate: end the war. The B-36, by contrast, emerged from uncertainty. It was designed in anticipation of a world that might fracture again. Its scale reflected not battlefield desperation, but strategic caution. Bigger wings, longer range, greater payload capacity, not because a specific target required it tomorrow morning, but because planners wanted the option. Options are a kind of security, but they also reshape expectations. Once a nation proves it can project power across oceans without relying on foreign soil, that capability becomes part of its strategic identity. The B-36 didn't just expand operational reach, it expanded strategic imagination. Suddenly, geography seemed less protective. That realization reverberated globally. Other nations accelerated their own bomber programs. Air defense networks expanded. Interceptor designs evolved. The arms race wasn't simply about weapons, it was about altitude, range, speed, survivability. And within that competition, the B-36 occupied a peculiar space. It was not sleek or supersonic. It did not rely on speed to evade threats. It relied on height, endurance, and sheer payload capacity. It was a monument to a specific strategic philosophy, that distance plus altitude equaled safety. For a time, that equation held. But equations change when variables shift. Jet fighters improved. Radar systems sharpened. Surface-to-air missiles began to redefine what safe altitude meant. The sky grew less forgiving. That's the quiet tension running through the B-36's operational life. It represented peak piston-era confidence at the exact moment the jet age was accelerating. It was both state-of-the-art and already approaching obsolescence. Yet there's dignity in that transitional role. History often celebrates the first or the fastest, the aircraft that break records or dominate headlines. The B-36 was different. It was foundational. It provided breathing room during a volatile period. It allowed doctrine to solidify before the next wave of technology arrived. And doctrine mattered. Strategic Air Command built its identity around constant readiness, aircraft on alert, crews rotating through shifts, maintenance cycles synchronized with operational planning. The B-36 became a centerpiece of that structure. Its presence reinforced the idea that deterrence was not a one-time declaration, but an ongoing condition. That condition required discipline, not just from pilots, but from an entire network of personnel. Mechanics, logisticians, engineers, planners, thousands of individuals sustaining a fleet whose primary purpose was to never be used in full. There's something paradoxical in that. The most powerful weapon is the one that stays holstered, but only if everyone believes it can be drawn instantly. And so the B-36 sat on tarmacs, its wings stretching wide under open sky, embodying both threat and restraint. Meanwhile, the memory of the B-29 lingered in public consciousness. It had flown missions that ended cities. It had carried weapons that reshaped moral debates for generations. Its name became synonymous with a turning point in warfare. The B-36, in contrast, operated mostly out of public view. Its influence was quieter, embedded in policy briefings and classified planning documents. It did not define a dramatic ending. It defined a tense middle, a prolonged balancing act. If you trace the story carefully, you see how these two aircraft form a kind of narrative hinge. The B-29 represents culmination, the peak of one era's industrial and military mobilization. The B-36 represents transition, the bridge to a world where conflict might never erupt openly, yet always looms in calculation. And beyond them both lies the broader arc of aerospace evolution. Lessons learned about pressurization informed commercial airliners. Advances in material science improved civilian aviation safety. Long-duration flight procedures influenced everything from cargo logistics to eventual space missions. The boundary between military innovation and civilian application blurred, as it so often does. In that sense, the legacy of these bombers extends far beyond strategy. They helped shrink the globe. They contributed to a world where crossing oceans became routine. They accelerated technological progress in ways that outlived their military roles. With the celebrated B-17, engineered by the Boeing Corporation. Perhaps their most lasting legacy is conceptual. They forced humanity to confront a new scale of consequence. The B-29 demonstrated the devastating potential of strategic bombing combined with nuclear capability. The B-36 institutionalized that potential into long-term deterrence doctrine. From immediate destruction to sustained balance. That is the journey. It's not a comfortable story. It's not purely triumphant. It's layered with tension, compromise, and moral complexity. But it is undeniably transformative. Two aircraft separated by a handful of years, carrying within them the weight of an entire geopolitical shift. The B-29 Superfortress and the B-36 Peacemaker did more than fly. They marked the moment when the sky stopped being merely a theater of war and became a silent arena of global equilibrium, where power, fear, technology, and restraint intertwined in ways that still shape the world today.